Welcome back to our science videos, our science lesson. In the last video, we ended in the substitution reaction and the classification of substitution reaction. We know that substitution reaction is classified to three main types. The first type, we have reactions between the acids and alkalis. This reaction is called neutralization. Okay. So the first one again, reaction between acids and alkali. We know from the previous years that acids is anything that start with H, like HCl. This start with H, so it's acid. Like H2SO4, it start with H, so it's acid. Except water. Water starts with H, hydrogen, but it is not an acid. So the second, alkali. What is the meaning of alkali? Alkali is anything in chemistry that ends with OH, like NaOH, sodium hydroxide, like KOH, potassium hydroxide. This is alkali. Okay, if we add an acid to an alkali, we form something called salt and water. We form salt and water, as we said before. Acid plus alkali produce salt and water. This process is called neutralization process. Okay. The second type, we have the reaction between the acids and the salt. The acid and the salt. Okay, salt, we will discuss what is the meaning of salt, but now we know the meaning of acid, anything that starts with H, of course, H. Okay, number three, the reaction between the salts and another salt and salt. So the reaction between salt solutions, two salt solutions. Okay, let's start one by one, type by type. The first type, we have the reaction between acids and alkali. Okay, let's start with that and see what is between them. As we said that this process is called neutralization process. Of course, neutralization process. What's the meaning of neutral? Neutral, neither acid nor basic. Okay, it's neutral. Not acid, not basic. Okay. So, as we said also, that if we add acid to alkali metals or alkali, it will produce salt plus water. For example, if we have an acid like HCl, hydrochloric acids, called hydrochloric acid, hydro from hydrogen, chloric from chlorine, hydrochloric acid. If we add sodium hydroxide to it, NaOH, sodium hydroxide, how we know that this is acid? Because it starts with H. How we know that sodium hydroxide is a base? Because it ends with OH. Okay, if we add them together, the H attached to the OH and the Na attached to the Cl. So this will produce NaCl plus H plus OH give us H2O. So the result will be NaCl plus H2O. Of course, we know H2O is a water and NaCl is sodium chloride with salt. Okay, so this is water and this is the salt. Okay, this is the main formula of neutralization process. Acid plus alkali or base give us salt plus water. Okay, let's continue. By on heating the product, the previous reaction, H2O evaporate and NaCl table salt remain as it is. If we want to isolate the NaCl, which is a salt that is dissolved in water, if we want to isolate it from the water, we just bring some heating energy, okay, and heat the product to isolate the NaCl from water, because water, of course, when heating it, it evaporates and the NaCl remain as it is. Number two, the reaction between acid and the salt. Here we know the meaning of salt, but we know also the meaning of acid. Let's make a small reaction. Okay, yeah, this is a reaction. We have an example of salt right here is Na2CO3. It's called sodium carbonate. Sodium from Na and carbonate from CO3. It's a group in chemistry. We know it previously in Medal 1, but again we have some groups in chemistry like CO3, like NO2, as we said in the revision video. Go back to the revision video. Like NO3, these are not compounds. These are called groups. Okay. So this is a salt. Okay, Na2CO3 is a salt called sodium carbonate. If we add HCl to it, hydrochloric acid to it, we know that's acid from the H on it. Okay, this will produce, what will produce? Na will come to the Cl, so it will bring us NaCl plus H2O, of course, water, plus CO2. Carbon dioxide, of course, the carbon dioxide will evolve. The carbon dioxide will evolve because it's a gaseous matter. Okay. This equation, again, we have sodium carbonate, Na2CO3, it is a salt. Okay, with HCl, it's acid. Okay, it will produce sodium chloride, salt, and water, and the carbon dioxide, CO2. Okay, salty solution with another salty solution. The third side we have salt solution with another salt solution. Like NaCl, of course, it's salt. AgNO3, silver nitrate, it's a salt. So what will happen? Divide it into two parts like this. Okay, the first part is positive, the second part is negative. Positive and negative. The positive one here will get the negative one here, and the negative one here will get the positive one here. But be sure that the positive one is written first. So the positive one here is Na will attach to the NO3, so NaNO3. Okay, the positive one here is Ag will attach it to the negative one here is Cl, so the product will be AgCl or ClAg. Yes, AgCl. Of course, Ag comes first because it's positive, so the product will be AgCl. It's called silver chloride. Silver chloride. So we have silver chloride, we have silver nitrate because sodium nitrate, sorry, sodium from Na, nitrate from NO3. It's a chemical group, not an atom. Okay, the silver chloride, its color is white precipitate. White precipitate. Okay. So these are the three types of substitution reactions we have. Number 3, oxidation and reduction. Oxidation and reduction. What is the difference between them? The difference between them is very easy. Let's take some examples of it and we will see. Oxidation and reduction reaction take place by losing and gaining oxygen. It depends on oxygen and hydrogen. The reduction, it is related to hydrogen, and oxidation related to oxygen. Let's figure out that. And losing and gaining electron, we all know this. Oxidation and reduction, losing and gaining oxygen or hydrogen. This is the first one. Okay. First one, if we have two elements, A and B, and these two elements began to lose electron. Some of them will lose one electron, and some of them will gain one electron, like Na. You know Na? Yeah, Na. If we add Na to Cl, okay, what will happen? This will produce NaCl. What is the result? The Na is positive, the Cl is negative. What is the meaning of this? This means that the Na will lose one electron, so it will be positive, and the Cl chlorine will gain one electron, so it will be negative. Okay, this is great. So what will happen to the Na? Na lost one electron, so the atom that lose one electron undergoes an oxidation reduction, chemical equation. Okay, and the atom like Cl that gained this electron is undergo reduction or gain one of electrons. Okay, this is great. So the atom which lose undergoes oxidation, and the atom which gain undergoes reduction. Another one. What happens when hydrogen gases passes over hot copper oxide? Like the copper oxide here, what's the color of it? Black, excellent. The color of copper oxide is black. We studied it before. Okay, the copper oxide CuO, if we add some hydrogen to it, the product will be Cu plus H2O. Okay, this is great. But let's figure out which one of them is acid or oxidation and which one of them is reduction process. First of all, let's figure out what is CuO. Cu lost one oxygen, it becomes Cu only, so it undergoes a reduction process, so that the element or the compound that lose one electron, or one oxygen atom, so it undergoes reduction process, and the atom like H2, hydrogen, that undergo or gain the one oxygen like this, so it undergo oxidation. Of course it's oxidation process. So hydrogen is oxidized because it be combined with oxygen, and hydrogen is considered as reducing agent because it took oxygen from copper oxide. While the copper, again, hydrogen is oxidized because it combined with oxygen. And hydrogen is considered as reducing agent. So hydrogen is oxidized and reducing agent at the same time. Reducing agent because it reduced the CuO. Okay, copper oxide also reduced because it loses oxygen. And the copper oxide is considered oxidizing agent because it gave oxygen to hydrogen. This is very important. So we have the definitions: oxidation, reduction, oxidizing agent, reducing agent. Okay, let's take them. Oxidation, it is a chemical reaction where causes the increase in the oxygen percentage or the decrease in the oxygen percentage in a substance. While reducing is a chemical reaction where causes the decrease in the oxygen percentage or the increase in the hydrogen percentage in a substance. Oxidizing agent, what is the meaning of oxidizing agent? It's a chemical or something which gives the oxygen or takes the hydrogen away in the chemical reaction. Reducing agent is a substance which takes oxygen or give hydrogen away in a chemical reaction. Okay. Letter B, oxidation and reduction, losing or gaining electron. What about the losing organ? Which one lose electron and which one gain electron? Let's figure out this. If we have Na, as we said, and Cl, as we said, it will produce NaCl, it's table salt. Okay, the sodium atom is monovalent because it loses one electron and it changes to positive ion. We know this before. And the opposite thing to chlorine. This process is called the losing of electrons. We will know. Yes, sodium. What will happen to sodium? Go. Here, the sodium. Yeah, it's oxidation. So losing of electron is considered as oxidation, and the gaining of electron is considered as reduction. Okay. So oxidation and reduction according to the losing or gaining of electrons. Oxidation is a chemical equation or a chemical reaction where the atom loses electrons or more in the chemical reaction, while reduction is the chemical reaction where the atom gains the electrons or more in a chemical. Yeah, this is again oxidation or oxidizing factor. This is a substance which gain electrons, and reducing loses electrons. Okay, this is easy, I think. Okay, if we have this example, A and B, reducing this gain electron and oxidizing or oxidation loses electron, like this. This A lost their 2 electrons, like this. Okay, these are lesson 1, and we have finished lesson 1. The questions will be answered in the classroom, inshallah. And goodbye. See you in the next lesson, inshallah.